Morning.
Yeah.
Good morning.
Good morning.
Okay, my name is DaianaToussaint, and today we're going to talk about lake houses and mostly the history that takes us to lake houses. So from data warehouses to lake houses, but we're also going to go through databases and other architectures. So a little bit about me. My name is Dagian Tousaint. I have been working in the industry for about 8 years. I started as a SQL developer, and about 2 years ago, a little bit more, I became a database administrator. I work for Miami-Dade Public Schools. I consider myself to be a data geek. I love data and everything that has to do with it, and I love to learn. So I'm also a co-organizer for the South Florida SQL Server user group. And the other day that I was browsing the internet, I came across this cartoon that reminds me of our life in tech. Because every time that we start learning something, we finally get comfortable with it, and then we turn around and there's something else to learn. So my goal today is to encourage all of you to keep on learning and to get excited about it and hopefully do it in a happy and fun way. So to keep the theme of climbing, we're going to climb our way up to different technologies, starting with relational database, then data warehouses, then data lakes, and then we will finish with data lake houses. And we're going to go through this journey by a store. There is going to be a climbing store that sells climbing products, gear. So we're going to see the different needs of data that trigger the different needs of different architectures. And of course, the name of the store is the climbing store because that's how creative I am. Okay, so we first start with our store, which we open a small shop with all our products. And let me ask you one question. What kind of data do you think a small shop might need to manage its daily operations? I'm asking you. Yes.
Inventory.
Inventory, yes. What else? Customers. Orders. Yeah. Exactly. All this inventory, sales tracking, customer information, all this information we're going to store it on the first architecture that we're going to explore, that is relational databases. So we're going to explore what they are and how they work. To understand it better, we're going to follow the buying process of Sarah. Sarah is going to go climbing for the first time this weekend, so she wants to buy some climbing shoes and gloves. So she goes into our website, registered into our website as a new customer, and once she presses enter, her information is going to be sent to our database. Then she starts browsing to our website and seeing all the products and all our website. When she's browsing through our products, what it's doing is reading the information from our databases. All this information is stored in the database in tables. We're going to have different tables inside the database. We're going to have one table for customers, one table for products, one table for sales, and all of them are going to be related by keys. And this is why this architecture is called a relational database, because all these tables are going to be related to each other by keys. So some of the advantages of features of this kind of architecture is that it gives you data management and security. Because in this architecture, you can select how much access do you want to give your users? You can give your users access to the whole server and all the databases you have in there, or you just can give them access to some tables, or you can go as little as giving access to only some rows. So that's some of the advantages and features. The second advantage is that the databases are on ACID. It's not what you're thinking. ACID stands for atomicity, consistency, isolation, and durability. I'm not gonna go technical for what it all means, but in general, it means that all the information in the database is going to be, well, the data is going to have integrity. So it doesn't matter if something happens while Sarah was purchasing her products, all the information is going to be in the database, or either all or nothing. So all the information, all data is going to be accurate and consistent, even if you have many more transactions, because it's an architecture that is built for that. Now, going back to our climate store, our business is doing great, so we decided to open a bigger store, and now not only we're gonna have a bigger store, we're going to have different stores in different locations. So of course with this, our data grows, and now we also want to make sense of the data that we have stored. And maybe we'll start asking some questions that we want our data to answer, like which products are most popular among different age groups or regions? How do seasonal factors affect the buying behavior of our customers? And what are the purchasing patterns of our customers over the last 10 years? So we go ahead and we create our reports against our database, and all of a sudden we start getting complaints that the website is super slow, the reports are not loading, and we go ahead and check the health of our database, and we realize that this database is on fire. Because the CPU is 100%, the memory, it has no memory, it's just a disaster. And the reason of this is because databases are great for small transactions like Sarah buying products, but they are not built for analysis. So when we start running complicated queries, and especially queries that have to go through time, many years back, it's just too much for the database to handle. So to point some of that limitation is basically on that, that databases are not meant for complex analytical queries. Another issue is that they cannot integrate data from multiple sources. Like we can have maybe reports that are joining tables in different databases. They are not optimal for that. And especially they cannot handle historical data analysis. So to overcome these limitations, we decided to move our data to a data warehouse, because these data warehouses are actually built for this kind of reports or data analysis. So we can have data from different sources, like different databases, CRM, or spreadsheets, and to store this information in the data warehouse, they are going to come and have a transformation, or go to an ELT process. ELT stands for extract, transform, and load. So what you can see it like we're going to have a backend that is going to get information from different sources, is going to transform it so it's uniform, and then we're going to load it in our database and in our warehouse. And this warehouse is going to have an design that is going to be different from relational databases. because here we're going to have a central table that is called a fact table, and then dimensions around it. And this is one of the schemas called star schemas, and this is the simplest form because you have others like a snowflake and galaxy and etc. So having this architecture within is going to be optimized for analysis, and more important than that, for historical data analysis. So now we can run all the reports that we have before, and even more like BI, and use reports for decision making. Okay. And in addition to all of these advantages, we also have security. We also have the same security and management that we have in the relational databases, and we also have the ACID properties. So going back to the store keeps growing, and now we're going to start offering new services. We want to start offering climbing classes and outdoor trips.
That looks wonderful. I love it.
Please come and see the one. So we start opening climbing classes and outdoor trips, and we start taking pictures and videos of these activities, and also open a social media account. So we want to also get all the feedback from our customer and add it to our analysis process. So now we're going to be faces new challenges, and those are the data warehouses. Since our data is growing, scaling data warehouses is going to be time consuming, and it's also expensive to scale. Now, data warehouses is also not designed to store unstructured data, that in this case, the unstructured data will be our pictures and videos of our trips and classes. Then the structure is not flexible, because with these new classes and new resources that are coming into our data warehouse, we have different structures, and for data warehouses they have to be designed in advantage. So it's harder to have this flexibility to accept new resources. To solve this issue, we now move to data lakes. So with the adoption of data lakes, now we can store all the data that are coming from all the resources that we have, like pictures and videos, and our data warehouse can also be a resource for our data lake. So what is a data lake? By definition, a data lake is a centralized storage a centralized location to store large amount of structured and unstructured data. So you can see it like in your computer, a folder where you can store everything there. And what is different with the other two architectures that we saw before is that in a data lake, we're going to store data in a raw form. So we don't have to do any kind of transformation like we saw that we needed to do for data warehouses. So this is going to give us new users, that we will have data scientists and deep machine learning, that they can go straight to the raw data and do all their processes there. And it also gives us the flexibility of keep the data raw, so just as it is, or adding some transformation if we still needed to move it to a data warehouse and do different reports and business intelligence. Okay, so some of the strengths that I said before, the data lake allows us to store vast volumes of data in different formats. It's easier to scale, and it's more flexible because it accepts data raw, so data, all the data as it is. We don't have to do any transformation because we don't have any structure set right here. And also it's more cost effective because the storage in the cloud is a lot cheaper than just buying hardware and things like that to construct data warehouse. And it's going to support different kind of analysis like deep learning and machine learning projects. Now, some of the limitations. Like the example that I gave you before of thinking of a data lake like is a folder in your computer. Just imagine that everyone in your family is storing all data, everything that they have in one folder. So it could go wrong really fast. And it could become what is called data swamp. That is mostly that we have so much data in our data lakes that it gets really difficult to know what we have there and how we can get it to get any kind of analysis. Data lakes also don't have the ACID properties that we had before in data warehouses and relational databases, so it's harder to manage and it doesn't have the security that we have before, and also the data integrity. And it also can require some advanced tools to extract that data. So to bridge this gap, what we need is a combination of a data lake and a data warehouse. So this is what gives birth to a data lake house. That's pretty much what it has is the best of the characteristics of both the data warehouse and the data lake. So again, we just like in the data lake, we can store different kinds of data, like structured and unstructured data. But what it makes it different to a data lake is that we're going to have a layered architecture in it. So this layer architecture first start with the storage, that it will be the data lake part where we store our information. Then it has management data layer where we're going to store the data, the metadata and schema enforced for all the data that we have. And also in this layer we are going to get back the ACID properties that we had before. So now we can assure integrity of all the information that we're going to store in our data lakehouse. It also, okay, and it also going to have governance and security. That is going to be, that is an advantage based on what we had before in the data lake. And with this, we don't have to do all the transformation and all the data enforcement and integrity is done in one of these layers. So we don't have to do any other transformations to be able for other analytical software to connect to our data, to the data, and it's still going to be useful for data science and machine learning. Okay, so to recap, some of the key features for this architecture is that it's a platform that accepts all types of data. It could be structured or unstructured. Supports ACID transactions and is also offered than data governance and security. And some of the limitation is that it's a pretty new technology, so it is still complex to adapt and it's going to require some learning. It also has some performance issues because, especially when you compare it to data warehouses and relational databases, that the performance there to get data is going to be a lot faster than in a data lakehouse because you have to go to all these different layers to get your data. And you can face some integration challenges with different softwares. So, to recap, especially focusing on the analysis side, data warehouse, we can store structured data. It has to go through a transformation to be able to be stored in a data warehouse, and we can use it for reports and business intelligence. For data lakes, we can store more types of data like videos, audio, and pictures. And it's going to be stored raw as it is. It could be used for machine learning and data science. And if you want to use reports, it will have to go to a transformation step. And lastly, we have what is our Lakehouse or data lakehouse. That is a combination of the best parts of the tools where we can have different types of data. We're gonna store that, and on top of that data lake, we're going to put an architectural layer that is going to give us back all the benefits that we have from the data warehouse, like security and ACID properties, and from there we will have another layer for abstraction that so the data can be used for machine learning, data science, reports, and business intelligence. So that pretty much concludes my presentation. So thank you, and I will be open for questions.
Any questions, ladies?
Questions, comments? It's my first time giving this presentation, so any feedback is welcome. Yes.
Yeah. When it comes to explain a little bit on issues with integrations, like houses, is it specifically due to schemas or specifically due to just tools that are out there that may not use the same type of integration?
Mostly for the tools, because in this layer I'm putting in really general these different technologies that you can use for this architectural layer, like Delta Lakes and Apache Iceberg, I think is another one, and I'm missing another one. And so the integration from those technologies to other technologies sometimes is tricky. So that is one of the integration challenges. And also the learning part, because you have to train your people to be able to use this new technology. Okay. Anything else?
I have another question. In terms of the transition from a lake to a lake house, is there a specific tool you recommend to do that, or is it just really a matter of flavor?
I think it depends on your industry, your work, and what are you familiar with, because depending on the technology, some of them use more Spark, and others use Python, others use T-SQL. So depending on what you're familiar with, it will be easier for you to adopt these new technologies. And I was going to say something else, but I completely forgot. So mostly, yeah, based on what you're already knowledge and familiar with, I will recommend going that route or whatever your business is requiring. Yes.
What's it like being a DBA for Miami-Dade?
Not allowed to answer those questions. No, like I would say that it's easier than other industries because we don't have a lot of, like, it's not like a retail that you have constant incoming of data and stuff like that. Like, we have a set schedule and we have your holidays that nothing is going on. So we are even off on 2 weeks from Christmas and then spring break, so I can't complain in that part. Okay. Any other questions? Okay, so thank you.
Thank you, guys.